So we were just talking about the different tools and tooling inside the environment, and you were talking about all the tracking of the models. But I actually want to maybe get a little bit more basic around the tools. So what platform do you guys work on, or what open source tooling do you enjoy working with or have worked with, just in general, just to get an idea and indication of, I guess, in the life of a machine learning engineer? Because I mean, for version control, for example, what do you use, or where do these models get deployed?
Yes, cool. Well, okay, so I think your first question there is the platform, right? So we are Google Cloud predominantly, whereas I've been working is in Google Cloud. I've touched a little bit into Amazon Web Services and like Heroku, which sits on top of, they use a lot of stuff like AWS cool. underneath, right? And the one thing I've not worked in at all is Azure, so I cannot deliver any comment there. Yeah, I love Google, right? It's a very, to get business value out of data-orientated approach to building these cloud platforms, right? Yes. Everything is focused around getting data analytics and business insights and stuff to the consumer, right? Yes. All the infrastructure is geared in that way, and it's super nice. Then your next question was on the tooling and stuff.
Tooling around
source
that,
projects. Yeah, cool. So Google offers a lot of stuff to manage these versioning and lineage and all of that
models
stuff.
Out of the box.
Yeah, all of these out of the box solutions, but as with everything out the box, it comes with a hefty price tag, right? And I've just in my personal capacity, I've experienced that if you go through a UI and it's all clickety-click everywhere and stuff, things tend to get quite messy. Yes. And sharing between people and continuation, if someone leaves, for instance, yes. is very difficult because it will typically be associated with an account, and then you need to go and dig into someone else's account yes. to find their models and stuff. Yes, exactly.
Sounds like you have experience there.
Unfortunately, yes. So I think the segue I'm trying to make is that when you fall back on these principles, right, yes. again, like versioning and lineage, and you stick to the basics, the Here's Now My Toyota Way stuff coming in again, right, nice. Of just ensuring that you get the fundamentals correct, like GitLab or GitHub or wherever you are, is probably the cornerstone of any enterprise seeking to do things, right? It's just
so that is quite interesting.
Yes, I would absolutely say that you need version code that everyone can agree on, that gets merged and code reviewed and all of that stuff across, right?
Such a basic thing, but 100% I agree. That's so
absolutely, absolutely, right. So I think that's maybe I think it's an open source tool. I'm not 100% sure. I think so. Yeah.
Look, it doesn't necessarily have to just be open source. I'm just trying to understand like what's your workflow, what's it doing. But I mean, you made a good point now where the UI is good and it's there, but you'd rather want to work in code and work with libraries. I guess that's.
Yeah. No, definitely. Then. Yeah, so let me just give me a second here, right? So we've got the Git hole, we've got the Git situation going. Then the other tooling stuff we work with is, I guess, the reason why I'm struggling a little bit, because it changes so often, right? You'll see the cadence on Google's changes are incredible. They're releasing new things weekly, daily. You can just see on all their documents, latest update date is yesterday or 2 days ago. Things are changing constantly. They've got new things in beta rolling out every day. So our tooling is not necessarily so important, right? Because the tooling is an extension of the principles and processes that you follow. It is just a means of implementing something, right? Yes. And that for me is the important part, is that we can take the principles we've learned in our team and shift it to any cloud house, so AWS, and we can go and apply those principles there. The tooling is just an artifact of whatever this platform is, right? It means to an end, absolutely. So whether we are working in Google's Vertex AI, which used to be AI platform, which used to be deployment manager and Kubernetes and whatever that line might be, the principles are still the same. You need your version code, which is Git's a great tool. You need to check your data. You need to lineage everything. You need to ensure good data governance, all of those things, right?
So the principles beat the tooling.
The principles beat the tooling every time. Yes. You can run, let's put it this way, you can run an on-prem system just as good as a cloud system with the good processes. right? You don't need
I mean,
the cloud.
I agree with that,
Yes.
100%.
So then exactly the cloud becomes just a different way of managing.
A different way. So obviously some tools may facilitate some things better.
Absolutely.
May have better APIs, may have better ways of operation, maybe more in the forefront, like you said, all those versions being updated. But that just simplifies you getting to your goal.
Exactly.
And yet you can still apply this in other ways and use other tools together to get to that end goal.
Yeah, no, definitely. And maybe another benefit, I know we've tangled on now to the cloud, but cloud upgrades are much more simple than doing an on-prem sort of upgrade. I think we can all say that, right? And the reason is because there's someone sitting behind the cloud thing. They want to service the customer.
They've abstracted a lot of that.
They've abstracted a lot of that stuff that needs to go on.
Yeah.
Yes,
that makes total sense. Yeah. So getting actually maybe going on that same trend now. In terms of the models that you guys have deployed, one of my questions is actually how many models you have deployed, but maybe that's a bit of a, could also be a misleading question. So maybe the question is more around when you do, how does model deployment maybe work, and model updates and that happening in the wild. So okay, let's start with how does model deployment work?
Okay, and then we get to the number of stuff. Okay, cool. So basically, there's two higher order categories of model deployments, right? You have your real-time models. So that could be like your recommender system where you go onto your Netflix and you're scrolling and it says, would you like to try something different? And then you say yes. And now they need to hit some endpoint and provide you with a bouquet of new things that you could possibly view, right? That's a real-time or an endpoint kind of model. And then you've got your run-of-the-mill batch jobs that run on set cadence every week, every month, every day, right?
Like pre-scoring things.
Pre-scoring kind of things, yes. So if we consider those two categories, right? So how an endpoint model, right? That goes into a whole realm of its own. So you could have like different models, say A/B testing. So, and there's a nice little thing. It's called, I think, multi-arm banded theory that gets applied there. Where cool. So nice little topics for people to go and Google, right? But basically, let's say you've got an endpoint model, right? Or let's say you've got an endpoint use case. I'll use a collective term rather. You've got an endpoint use case for recommender engine, right? And now you've got a bunch of models sitting underneath that, and they'll randomly pick different people, right? Or they'll be applied randomly to different people, and depending on how successful the response rate is for each of these different models, this one might get used a bit more because it's got like an 80% success rate with people actually picking one of those. And so this one will get promoted. And then what's lying underneath all of those models is maybe data scientists, right, who are developing new recommender models. They will then hand it over, for instance, to a machine learning or MLOps person who will then ensure that the data auditing, the feature store auditing, all of that stuff happens, right, and is tracked and checked over time, and alerting is on it. And then there's a promotion process. So once that all gets signed up, maybe they'll then say, okay, cool, well, we've got 10 models that's currently running in production. This one's doing really great, so we're not going to demote that one. We'll demote one of these that's not doing great. Cool, we'll promote this one up. Oops. Then that'll go in, right? Then, depending on that one's performance and tracking, we can see over time, great, okay, cool, this one's doing really well. What's the characteristic there? Data scientists will develop a new one, demote one out, promote one up. That's just
I just love that rollout example, because it's like if models then tend to degrade over time, then you really have other almost models in the wake, challenger models, what you may want to call it like that, where it's like, hey, this guy's looking to perform really well and starting to perform, or maybe performs well in a certain section of the population, and then you're identifying new ways. Because I mean, at the end of the day, again, you're trying to, in the recommendation example, provide good recommendations for people, and the better you can do that, no matter how it gets done, even if it was a person saying, you know what, I know PT, I'm going to give him a recommendation.
Exactly.
And then that would be great. But now you've got all these models and they are providing these different recommendations and they're being, yes, it's cool.
Yeah, so that's on the like live scoring endpoint kind of situation, right? Okay. So that this high cadence, it's normally quite costly because you need to have certain uptimes. You must make sure the infrastructure services these things. They can't go down, for instance, right? Then on the other side of the spectrum is the run-of-the-mill batch kind of jobs that needs to run. So I'll just make an example, it might be easier. So we've got a few models in the fin sector that need to run every month, right? And there's a set population that they look at. They score this population, they provide the score is a propensity for someone to not pay, so to become more delinquent, like I've said earlier, and that's it, right? So it's a model, it needs to run, it needs to just score this population, produce the scores get checked against the baseline from the data scientists, we check tracking, feature distributions, blah, blah, blah.
Would you say that's easier?
Yes.
Okay. Yes. Because you have got more time, it's once off, you can almost double check things.
Yeah, you've got a lot more time.
It's not as risky as a more real-time model.
Yes.
And then why does that work like that actually? Why is that not a real-time model, for example, that batch one?
Well, that's interesting, right? So that's a good question. So I was at a conference, DataCon, a few years ago, I think 3 years ago, and the NetBank head of data made a very valid point that stuck to me. And he said the response of the model needs to fit the cadence of the business decisions made on it, right? Okay. And you aren't in real time going to decide whether these people are going to roll next month. I mean, it doesn't make sense for you.
There's no point in doing it every second or every day.
No, it makes no point, right?
Yes.
So you then have your 10 days to analyze this data and make sure that you then use this data in an appropriate manner, whether you send it to a call center or wherever this might go, or make new offers or send them on to debt review or whatever it might be. But the rate of change there and the rate of business decisions needs to support the rate at which you deploy or activate on this model, right? Whereas with this real-time situation, you are making real-time business decisions, right? So you need to roll those things out. Yes, exactly. Yeah.
But I love that. So just to rephrase that, so that what that means is that decisioning or the prediction needs to fit the cadence of the business decisions.
Made on top of it.
Made on top of it. Yes. So whatever the data is, the frequency needs to match how the other business performs. Exactly. But I almost have a counter to that, where I'm thinking, if it suddenly is possible to do predictions in a more real-time fashion or more frequently or second by second, then it could also change the business again to be like, we never knew this could happen because in the past we did it this way because of constraints, and now suddenly it can happen earlier. And actually, the reason I'm mentioning this is I'm thinking of like a planning algorithm where the plan used to only be generated every quarter, but now suddenly it could be done every week, and that changes the business and the dynamics in the business. Yes. So that could also happen then.
Yeah, absolutely, right. So I'll give 2 examples quickly. So the one example on the planning one, right, is the current structure is that they do a weekly planning. So there we've got the models that run weekly, right, and tell them what to buy at what time, in which quantities, right? So then they know, taking in the lead time model, so we know that certain things might take a week or 2 weeks to arrive. So we need to order it at this point and in this amount for it to get into the store at X point, right? Okay. Then the other example I wanted to give you was the one that you spoke about, the customers now and if you could score them, right? Yes, so the reason I didn't go that avenue is because very often in sort of the credit area, the propensities or these scores go into call centers, right? So it's not like you pick up someone's going to default and you phone them immediately and tell them, you will pay now. It's sort of like within that month you contact them to make sure that they pay in a subsequent month or within that month.
There's just no reason for this.
There's just no reason, right? So then there's another one that we've got is a real-time loan allocating model, right? And so what's cool about this is to what you're saying now is previously they didn't have this facility available, and so you would apply for a loan and then you can come back in 2 or 3 days and then they'd have a bouquet. You can have $500 because you qualify for 500. Yeah, exactly. Yes. But now we've got a model that actually does that for us, and you apply online for your model, and within a second or two, apply online for your loan, and within a second or two you have a response that says, okay, cool, you qualify for X amount. Yeah. So the business decision fits the model requirements. Okay. Or dictates the model requirements. Yes.
That's cool.
Very cool. Yeah.
Sure. That was quite a super interesting conversation now, and we went deep into quite a few interesting topics around machine learning engineering. So I'd just like to say thank you, Carl. Thank you for attending this first episode around machine learning engineering.
No, awesome. Thanks for letting me talk so much.
Yeah, no, I think there's some super interesting content that I do believe a lot of people will be interested in. So if anyone has any questions relating to the stuff we just spoke about, and want to dive a little bit deeper, or want us to dive a little bit deeper into any of the topics, more than welcome to leave any comments. And then, yeah, that's it. Thank you so much, Carl.
No, awesome. Thanks for having me.
That's it.
Nice. Nice.
Like a fist bump.